Hello guys, this video is for lesson 10.3. So let me start off with a little background. Okay, so when I learned how to find the area of regular polygons, which is what this is about, my teacher, Miss Laureen, she didn't tell us about the word apothem and that there was a formula specifically for regular polygons. What we learned in my class is we learned that regular polygons can be divided into triangles like this. And since we know the formula for a triangle, 1/2 base times height, we would need this base and we would need this height to find the area of this one triangle. And then we would multiply it by the number of triangles. So we would find that and we would multiply. So we'd go times the number of triangles. So likewise in this one, no, we're not doing pentagons in this lesson. That's going to be in 10.5, but we're doing hexagons. And hexagons are regular polygons just like pentagons are. So we would do this, and we would find this base, and we would find this height, all to find the area of this triangle. So same formula. We would go 1/2 base times height, and they would multiply by the number of triangles, like that. Well, this base is the side of the pentagon. This base right here is the side of this hexagon. And if you, somebody noticed, a mathematician noticed, that if you multiply this base times the number of triangles, so this base times this number of triangles is the perimeter. So base times the number of triangles is the perimeter of the shape. I'm going to call it capital P. Same thing here. This base times the number of triangles gives you the perimeter. So same thing here. So they decided to take that base times the number of triangles and just replace it with perimeter. And that height, so as not to be confusing about whether it's the height of the pentagon or not, they decided to name it that term that we learned on your tip chart, apothem. And so the formula became this. The formula became, to find the area of a regular polygon, you take 1/2, because 1/2 is in the triangle formula, times the base times the number of triangles. That base times the number of triangles is the perimeter, times the height of that triangle, which is called the apothem. So this is the formula we're learning today. It's the same formula. So, and it works on this one too. So the area would be 1/2. This base times the number of triangles, base times the number of triangles, is the perimeter of that hexagon, and this height of the triangle is called the apothem. So this is the formula we're learning today, 1/2 perimeter times apothem. And for some problems, if the problem just says find the area of this shape, you can either do it this way, find the area of one triangle and multiply it by the number of triangles, or you can use this new formula, 1/2 perimeter times apothem, because they give you the same exact thing. Okay, so now on to the notes. So put your date here, put your name here. I'm going to leave that off so that I can use this for some other classes. All right, the formula for finding the area of a regular polygon is area equals 1/2 perimeter times apothem, where P stands for the perimeter of the polygon, perimeter of the polygon. I think I intended just to put perimeter on that line. And A stands for apothem. Let me make sure y'all can see that. Yep. Okay. So these first couple problems, they're giving you the apothem and they're giving you the perimeter, and they just want you to use this formula right here to plug that in. So find the area of a regular hexagon with perimeter 60 and apothem 8.7. Write down the formula first, just like we do with all area problems. Always write down the formula first. 1/2, and then we're just plugging this in. So you're plugging in perimeter. We're plugging in apothem. And then we just have to do 30 times 8.7. So grab a calculator if you want. Practice multiplying by decimals if you don't want, because that is good practice for basic skills tests. you get 261. 261 inches squared. Remember, this is still area, so inches squared. Okay, the next one is the same kind of problem, but they don't directly give you the perimeter. It says find the area of a regular pentagon with side length of 8, and the apothem is 5.5. So if we write down our formula, 1/2 perimeter times apothem. If you read the question, they did not directly give us perimeter. So I'm going to leave that blank for a minute. I'm going to bring down the half. I'm going to leave perimeter blank for just a minute. They gave me the apothem. Okay, so they didn't directly give me the perimeter, but I can find the perimeter because it's a pentagon, which has 5 sides, and the side length is 8. So the perimeter is 5 sides times 8 centimeters. It's 40 centimeters. And so I'll plug in a 40 right there. And then half of 40 is 20, and 20 times 5.5 is 110. 110 centimeters squared. Let me make sure I'm right by that. Yep. So some problems are going to be like that, where they're giving you perimeter and apothem, or they're giving you information to find the perimeter and the apothem. Okay, this is what the majority of the lesson is about. They're giving you some information about a regular hexagon, or in this case, an equilateral triangle. There's another hexagon on the other side. Anyway, and they're asking us to find the area of it, and they're going to give us some kind of information. So the side length is 6 meters, and they want the area of this entire shape. All right, so you have some options. You can either find the area of this one triangle right here, and then multiply it by 6, because there are 6 of them, or you can do this new formula, 1/2 perimeter times apothem. So I'm going to show you both ways. I'm going to do 1/2 perimeter times apothem, and then I'm also going to do it by 1/2 base times height times, I'm going to put a dot instead, times the number of triangles. And you'll see that it's the same thing. So whatever you prefer. All right, so first let's plug in what we know. We can find the perimeter pretty easily because one side is 6 and there are 6 sides, so the perimeter is 36. Now, to find the apothem, first of all, we need to draw an apothem so we can even see it. Before I draw it, let me just remind you of the little preview lesson that we had last time. So in the preview lesson, we were talking about calculating this angle right here. See, there are 6 of them, right? 6 of these triangles, and the whole way around would be 360. So if you take 360 and divide it by 6, this right here is a 60-degree angle. When I draw in that apothem, which is what I'm trying to find, that 60 is going to get split. So when I do area of regular polygon problems, you'll always see me do this. I always pull out this little half triangle right here, because this is where I need to do my work. This is what I need. I need this apothem. This is 30. Okay, when I drew in that apothem, think about what happened to the 6. The 6 also got split. Not only that 60-degree angle, but that 6 got split. Now, that doesn't always happen. It always happens in regular polygons, though. All regular polygons, that will happen, because this will always be an isosceles triangle, because this is a radius and this is a radius, and they're equal. So the only way that would split the angle and this side is if this triangle were isosceles, and it always will be in regular polygons. All right, so then think back to chapter 8. And in chapter 8, across from a 30-degree angle, we called this A. Just grabbing a red pen real quick. This is A. Oops, I'm going to put it here. And this is A radical 3. This is twice A. I'm not going to put that because I don't need it. All right, if A is 3, then this height is 3 radical 3. That's the apothem, 3 radical 3. So half of 36 is 18, And 18 times 3 is 54. So this is 54 radical 3. And you can leave your answer just like that. This is meters squared. You can also multiply that if a problem asks for it. So it's about 93.5 or approximately 93.5 meters squared. Okay, if you want to do it the way I used to do it in school, you do 1/2 times base. We still need that apothem, so there's no shortcut to doing this work and to getting that distance right there. So the height of that triangle from this same method would be 3 radical 3, and then we multiply it by how many triangles there are. See, this right here will give us the area of this one triangle because I used 6 as the base, and the height was 3 radical 3. And then we're multiplying it by 6 of them. So this is how we used to do it in school. And you can see that it's going to be the same thing because this 6 times 6 is going to give you that 36. You get the same thing. So half of 6 is 3, and 3 times 3 is 9. So this is 9 radical 3 times 6, which is 54 radical 3. Same answer. And I do not have a preference, so whichever one you like. Okay, next one. It says find the area of this equilateral triangle. See, this formula or this section is only about regular polygons, and an equilateral triangle is a regular polygon. Now, you may be wondering, what do you do if it's not a regular polygon? What if it's irregular? Well, here's a little picture of that. Like, here's a pentagon that's not regular. We would just divide it into shapes that we could find the area of. So we would find the area of this square, or it could be a rectangle, I guess, and then we would find the area of this triangle and we would add them together. So when the shapes are irregular, you just have to divide them up into regular shapes. Okay, so here's what's happening with this one. It's an equilateral triangle, and so you guys will see that I always start with a center, and I draw this bottom triangle down here. There are 3 of them, but I'm looking at this bottom one. And then I calculate this angle, so 360 divided by 3 of these angles makes 120 degrees, so this is 120 degrees. They gave me the radius, which is 4 centimeters. And what I need is this apothem. Actually, I need the apothem and I need this side. So when they give you a radius, they're not giving you anything you need in this formula. So you have to find the height of the triangle, the apothem, and this length so that you can get that whole side. So here's our formula. 1/2 perimeter times apothem. Okay, I'm working in this triangle right here. The reason I'm always working in this little half triangle is because of the right triangle. Right triangle is where we can find missing values. Okay, so that 120 got split, and now it's a 60. So this is a 30, 60, 90 right triangle. It's just oriented differently than it was in the last problem. This is 4. Okay, so here's the labels from chapter 8. Across from the 30 is an A. Across from the 60 is A radical 3. Across from the 90 is twice A. So what they gave me is the doubled one. Twice A is 4, so that means A is 2. I just found the apothem. And this distance is 2 radical 3. So those are the measures that I'm going to need. All right, on to my formula. So I don't have perimeter yet, but I have apothem. The apothem is 2. All right, let's talk perimeter. So this 2 radical 3 right here is this distance. This is 2 radical 3. So the whole side is double that. It's 2 of those. So this whole side is 4 radical 3. That's how long that is. And so the perimeter is 3 of those. So the perimeter is 4 radical 3 times 3 sides, which is 12 radical 3. 12 radical 3. So now I've got all the parts to my formula. And you can go 1/2 of, actually if you do half of 2, that's, anytime you have a 2 in here, half of 2, that's just going to cancel. Half of 2 is 1. 1 times 12 radical 3 is 12 radical 3. 12 radical 3 centimeters squared. Okay, again, you could have done the area of this triangle, which would be 1/2 times 4 radical 3 times 2. Remember that height's 2. And that would be 4 radical 3, and then multiply it by 3 triangles, and you get that same answer. Okay, example 5. Example 5, I added this example in because I had a test question, and you may have this same kind of test question on your chapter 10 test, but once upon a time I had a test question that was phrased just like this, and some kids didn't understand the directions, so that's why I put it on here, just to explain the directions to a problem like this. So this is not asking you to find the area, so we're not using that formula that we're talking about. They're just asking us about some of the angles in the question. So it says, find the measure of the angle formed by 2 consecutive radii. And part B, find the angle formed by a radius and a side. Okay, so let's answer part A first. The measure of the angle formed by 2 consecutive radii. So draw a radius. It doesn't have to be that one, it can be any radius. And draw one right next to it, draw the next radius right next to it. I kind of tend to camp out in this bottom triangle right here when I do my work, but some people draw it like that. So that's still a picture of 2 consecutive radii. It says find part A, the measure of the angle formed by those 2 consecutive radii. So that's this angle right here. This is angle A. So if you see this question on the chapter 10 test or on a quiz, that's what they're asking you for there, the measure of that central angle. So angle A is just the measure of a central angle. And we've done that a few times now, but it's 360 divided by how many sides there are, because that's how many triangles there would be in here. And so that gives you 60 degrees. And then it says, part B, find the measure of the angle formed by a radius and a side. So here's a radius, and here's a side. So this is angle B. This is the one they want for angle B. Okay, this triangle will always be isosceles because this is a radius and this is a radius. So no matter what shape you're working in, this is going to be an isosceles triangle. This one in a hexagon just happens to be a little special. Okay, so let's look at what's happening. Now remember, I'm not finding area, so I don't need the apothem. I'm just talking about angles here. This is 60. Well, if you take the angles of the triangle, 180, and take out that top angle, that leaves you 120 degrees. And since these are the same, because these are all radii, then we learned in chapter 3 that that means these base angles would be the same. So divide that by 2, and you get 60 degrees each for those bottom angles. So these bottom angles are also 60. Now, this is a special case. So in every single kind of shape, pentagons, octagons, this is going to be isosceles. But in a hexagon, this happens to be equilateral. We find out that these angles are both 60, just like this one is, which makes them all the same, which actually makes it equilateral. So this is a special case. These will usually be different answers. See, if this was a pentagon, that would be 360 divided by 5, which would give you 72. And if you take 72 out, that would leave 108, and divide 108 by 2, and you get 54 degrees each. So it would be a 72 and a 54 and a 54. So this is the only case where it actually happens to be equilateral. So if they happen to give you a radius in a hexagon, that radius and that side are going to be the same because it's an equilateral triangle. All right. Example 6. they want us to find the area. So we're back to area problems. We're using this hexagon, so I'm not going to redraw it. I really just want to work in this triangle. And so I'm going to write down the formula. Area equals 1/2 perimeter times apothem. Or you can do 1/2 base times height times the number of triangles if you want to. I'm going to draw in this apothem right here. And that's the triangle I like to work in. That 60-degree angle just got split. Shh. Shush. Oops, that's a 60. And they gave me radius. Radius 10 inches. So across from the 30 is A. Across from the 60 is A radical 3. This is twice A. Anytime you're watching these videos, guys, and taking your notes, you can always stop the video, try the problem, and then turn it back on. I think I've mentioned that. Twice A is 10, so that means A is 5. So this time the A is down here. And then across from the 60 is A radical 3, so this is 5 radical 3. Okay, I now have enough information to plug into 1/2 times perimeter times apothem. So this is 1/2. All right, let's find perimeter. This distance is 5. So if I carry this back up to this problem, that's this. This is the whole side of the triangle. So if that part's 5, so is this. That makes the side of the triangle 10. See, I was telling you a minute ago, since this is equilateral, the radius 10 and the base 10, it winds up being the same thing. That only happens in hexagons. So this perimeter is 60 because one side is 10 and there are 6 of them. And then the apothem is this distance right here. That's the height of that triangle. That is 5 radical 3. So half of 60 is 30, and 30 times 5 is 150, so it's 150 radical 3 inches squared. And again, if you don't like that answer, you just multiply 150 times radical 3. Looks like this in your calculator. And you get approximately 259.8. So it all depends on how they ask it in the question. If they ask you for radical form, you leave it like this. If they ask you for a decimal rounded, you write it like this. All right, that is lesson 10.3. So there's some homework on that, and y'all have a great day. Bye.